You should be good. All right, everybody. Happy Friday. Hope everyone's enjoying it, ready for their weekend tomorrow. We will get started. All right, so we're gonna run over some mixing valves today. Now, one of the big ones with mixing valves is everyone kind of determines, and we go back and forth over, well, we got to talk about master mixing valves. And when you're talking about mixing valves, really what you think of is a total family of valves. So one valve is not going to create all of our solutions. We have to have the entire family when we're working on mixing an entire building. So up here at the top, we'll have multiple different valves. We'll have more of our SH version, which is our low flow version. Say we have a building that we don't have a return system, so we're not going to have a lot of minimum flow. We'll work with our SH version. If we come over here to our 430 series, that's going to be more of a mixing valve. We're able to jump into when the building has a return, and we're able to meet that 7 to 10 gallon minimum differential on that water return. And if we come over here, our ETVs, which are emergency mixing valves, which are going to go to our eye wash stations and our showers. But we can also jump all the way down to some of our smaller mixing valves. So if we're doing like a small bank of lavatories, even our showers or even our individual USGBs, they all have to work together to create a total family of a mixed outlet temperature of whatever you're looking for. And basically what we're doing is we're just taking really cold water, really hot water, and we're able to blend it together to make that safe, desirable temperature. And when you think about temperatures, and trying to keep them at a safe degrees, you'd be amazed, and I'm sure you guys all know, but you'll be amazed the scalding ratio between 120 and 140. 120, you're not actually going to get scalded. It's going to burn you, but a major difference between getting burned and then being scalded. And overall, 120 is not going to scald you. It's going to burn. It's going to hurt, but ultimately, you can hold your hand under there for a while. But for every degree we raise up on, we jump into having the potential to get scalded. And it's amazing how often this actually happens. Actually, when I started my career almost 10 years ago with Disney, one of my first mixing valve calls was, I won't give you the location, but it was in Northern Ohio. It was actually run by the state, and it was for people with disabilities. And the poor guy just ran his bathtub, and he filled it up. But when he stuck his hand back over to check the temperature, it was sitting right around 100, 145 degrees. Instantly burned his hand, which scared him. He fell back into the tub and really burned himself up. So don't take mixing as just an aggravational thing of, oh, we've got to put this in. This really does jump into the safety of the building between, people with disabilities, young children, or we even get up to the elderly. We really got to make sure that we're not melting people's skin off with the water that we're trying to provide. Because as you know, as many of the buildings that you design, our laundry room may be sitting at 140. And, we'll turn around and our lab temperatures, have got to be down at about 105. Showers got to be 110. Well, how do you meet all these requirements with just one valve? And honestly, you can't. So we're going to jump into, a couple different features. Now, we don't have, if you've ever sat through one of my presentations, you'll know that I can speak for hours upon hours upon hours. But Jim's only allowed me 1 hour to talk to you guys. Next year, I'll ask for 3. We'll see how my attendance rating drops. But, we have to take every single bit of this and make them a family. And we got to bond everything together to really make sure that we're giving that desired temperature, not only to the building, but also to each individual fixture that we have running through our system. So obviously, here's our whole family. So we're talking about our 116s, which are our bath and showers only, 117s, which will be our master mixing, which is going to take care of the building. But then you also remember, we're going to jump up to our 1070s and our 1071s. And again, we have to maybe take our master mixer, set it for 125, take our 116 tub and shower valve, bring it down to 110, and then maybe even drop it down again when we get to our 1070s, get that thing down. to about 120. And then also remember, we've jumped down to our emergency mixing fixtures, the ones that no one ever uses. But remember, when you have to use that eye wash, and I don't know if any of you guys ever have, but one time in my career, I got a little PVC cleaner in my eye, and I was really, really happy when I turned that eye wash on and I didn't have 120-degree water splash them in the eyeballs. It was actually set at a nice, cool 85 degrees, which allowed me just to sit there for about 30 minutes and let the water pass through my eyes, and get it cleaned up. So, you get into extremely cold water, you're not going to be able to hold your face underneath it. Very hot, you're not going to hold your face. So it's very important that with this entire family of mixing valves, we get everything aligned exactly the way it is. So, and again, I kind of laid this out showing the entire family. We have our 1017 master mixing valve, which is basically able to feed our entire building. But then we're able to jump up into our showers, over to our labs, and then really kind of dial our entire system in to hit all those required temperatures for each individual fixture. Now, because Jim was so rude and took 2 hours away from me talking and only gave me an hour, we're going to concentrate a little bit more on today. It's just strictly our master mixing valves. We'll get into some of the thermostatics internally. How do they work? What's going on inside that brass body? We'll also talk a little bit about our high-lows. Now, when we talk about the operations of our master mixing valves, we can correlate that over to how the internals work on our mixing valve here and in our low flow here. And what I'll be talking about mainly is how to set our temperature on our low flow, on our high flow, and then we'll jump into why is that PRV there? What is it doing? That's not made for mixing water. That's more for pressures. But we'll discuss how this operation all works. And once dialed in, it works great. But I will tell you, very, very time consuming. And this is just a single high-low. We have our low system, our high system. We're looking at about an hour to really dial it in. But I've done a couple projects. I got pulled into one down in Lexington for UK. And what they had is they had an actual 6-valve high-low system. I believe me and my counterpart down there, we had over 5 hours kind of balancing, adjusting. We'll go through that. And then we're going to move right over into our digital. Why would we want digital? What's the difference between digital and thermostatic? Why would we move up to that digital world when, my thermostatics have been working great for all of my buildings? We'll talk a little bit about that and some of the new aspects and a lot of the features and benefits of this of the new digital world. So let's start off with a little thermostatic. What you're going to find is for years, the designs and internals have all changed. We started off way back in the days where we're using bimetals, and when we get into thermostatics, the easy way to think about it is all operating off of expansion and contraction. Everything that's hot will expand, everything that's cold will contract. And we started off back in the 1900s with more of like a bimetal where, we're running water across metal. When you heat it, what happens? It will expand. As it cools, it will contract. Moving away from the bimetals because it's just not very accurate. It takes a while for that metal to heat up, and it takes a while for that metal to cool down. So it wasn't very accurate. We weren't able to stay within that code of plus or minus 7 degrees to keep it in there. And as we spoke about, our temperature we have to be there, because if I need my water at 120 and I have a 7-degree plus or minus, well, 120 to 127, just that 7 degrees will result in, hey, this is way too hot. And you will notice a 7-degree difference. As we moved up in technology, we start doing more of a gas or liquid filled. It's great operations. I do believe there's a couple manufacturers that are still actually using this theory. I don't believe we're having any real issues with it, but it's just older technology. Once we start getting up into the 2000s, now what we're doing is using more of a wax-filled element. Okay. And if we're looking at this wax-filled element, we'll be talking about this a lot today, just when we're talking about thermostatics, is when you heat that wax, obviously it's going to expand. But when it cools down, because it's just wax, it'll cool down extremely quick. And we don't want it to heat up too quick and cool down too quick. So actually what we've done inside all of these wax elements is we add graphite, which obviously graphite's more of a metal-based carbon, where basically that carbon's able to hold on to the heat just enough that it will heat it up, but then it will, because it's in the wax, it will cool down a much quicker than just our old bimetal. So it's a better accuracy level. We're able to keep our temperatures closer into adjustment because, as you know, we got to stay within that plus or minus 7 degrees over that 60-second period. And if it cools up and goes too, if it drops too quick or if it raises too fast, we're going to start getting some jagged spikes in our temperatures. But obviously, we go too slow. We want this thing to shut off, and it may take a while for it to cool back down. So these are all the old technologies that we're using. Like I said, the liquid filled, I believe there's at least one manufacturer that's still using that. And then the wax filled element is what most people are using when we're jumping into it. And again, it's all strictly based on expansion and contraction. And the way these things operate, and there's that wax filled element sitting right over here to your left. If you look inside, what we'll have is, I normally call this my motor. This is what's adjusting up and down, my element, and then my spring. So what's internally, what's happening is, as my water enters in, our water is going to hit this element. Once this element gets too hot, it will start to expand. But because our pin is sitting right up here on our brass wedge up here at the top, it won't allow it to raise up. So what it's going to do is it's going to start to push that down, pushing it more into the closed position. As the cold water hits, it'll jump back up and contract back in there. Now remember, this is not strict. This is not just for this one valve right here. Okay. If you look at that family, every one of these valves that we have in this picture here, we're actually using this wax filled element to operate. So what's crazy about all this is all these valves look different. They're used for different situations, different projects, but internally, they all have some sort of element that's going to allow this to get hot, expand, get cold, contract. And what's going on is inside where our motor is, as this will start to expand, we'll push down, actually shutting off our cold water, or I'm sorry, excuse me, it'll expand, shutting off our hot water, allowing more cold water to enter the system. As this element, more of it gets, as it gets cold, it'll start to contract, slowly bringing it back up, shutting my cold off and allowing more hot to run through it. So that's the whole theory. It's as we expand, we'll shut water off, allowing cold to go through. As we contract, shut our cold off and allowing more cold. So we're able to blend it back and forth. And all that blending is actually going to happen right in this area. As it passes through, we'll hit our element and all the features in here, start to spin that water, mixing it right at that point, and then sending it out to our system. If this was just an open range, what we would have is half our pipe would be cold, half of it would be hot, especially if we're like a 75-25, most of it's going to be cold and we've got a little hot. So it doesn't mix till it gets pretty far down the line and blends it together. So what we got to do is somehow we got to figure out how do we blend it. So we got to keep all these features in here to really mix that water because we need it to be mixed right outside the valve. We don't want to say, hey, 10 foot down the line, that's when we're blending. We need it to blend. We need to hit that desired temperature as soon as we leave that valve. But here's some of our issues when we're running into, we get into these thermostatics. And, if you guys have been in this trade for years, you're going to find out very quickly that every manufacturer, and we'll just talk about Powers because that's who I'm with, but 99.9% of all manufacturers out there are going to tell you that, hey, this valve here needs to be completely rebuilt a minimum of once a year. The reason we're doing that is just water quality. And I'm not talking about dirty water, water that doesn't taste good, but if we get water that is extremely hard, what's happening in this system is we will get a large scale buildup on top of this element, which then once we have a large calcium buildup in this area, if hot water is coming up to try to touch this to make it expand, it takes forever. So our water gets cold in the building. And so eventually that hot water heats up to calcium and then it'll finally heat our element, allowing it to expand, pushing this down, allowing more hot water to run through. But then when our cold water will come over and hit that element, it takes a while for it to work through that calcium base to finally hit that element and allow it to contract. So we'll run into buildings where, hey, it's been working well for years, but I'm about 2 years, and I noticed, hey, we get a real hot glug or a real cold glug, and we're kind of all over the map. And what you're going to find is, because we're only working with expansion and contraction, and we're doing it with pieces that are stable and set inside a valve, there's no way for that to move it and shake it off and get, kind of get off of me, let me work. You have to actually physically rebuild this thing. And like I say, I will stow it out. My word is at minimum at least once a year. Now, if you guys have ever been in building maintenance, you will find out nothing gets maintained. It only gets maintained when it breaks down. And normally it's at a senior living center where the state's been there twice. And then you'll get that, hey, the mixing valve you designed, or for me, the mixing valve you provided, it's not working. When we take these apart, our biggest nightmare is just hard water. You actually get hard water deposits built up on these O-rings, which will not allow this to slide. Large calcium buildups on our element, again, doesn't allow it to expand and contract. And that what's going to happen then is we have a large fluctuation in temperatures up and down, back and forth. And it's because this thing is just stuck in a position and won't work at all. Other features we'll have on these, if we have them designed with those valves, are we actually have service checks built into these. So it does allow you to shut this off, get in here and rebuild it. And then also strainers. And again, if you've ever sat through any of my presentations, I don't care what piece of equipment we're talking about, I always stress the strainers. Keep the garbage out of my valve, and this valve will operate for years upon years. Dump a bunch of sediment and debris in here, and it won't work. So strainers are a big one for me. I'm always pushing strainers. Keep all that garbage, debris, and just things that are just floating around in the system. Let's keep it out of the valve that you may have just spent $2,000 on, and just one simple screen will really save that. And again, we talked about the blending issue, what's going on with that. And again, if you guys have questions, like Jim said, please throw them in the chat. Also, the last slide, I provided you guys with my email and my direct cell phone. If you have individual questions, and I don't care really where you're at, if it's across the country, I don't care, because a thermostatic mixing valve in New York and in California, they operate the same way. So if you have questions on thermostatic or digital, I'll throw my number out and try to help you guys troubleshoot and kind of get through your system. So, but let's get into what I'm sure everyone is more wanting to hear is more on of our digital. Why digital? Why would we take something that is going to blend hot and cold water and make it digital? Why is it so important? And one of the main ones is what I talked about before is, these systems, it's very critical to keep our temperature levels at the desired temperature. So if you need it at 120, we need to keep this building at 120. If I need 85, 90 at my emergency, we have to keep it there. We can't just say, ish. The state doesn't take too well to that. So if they do come in and they're going through the building, they will check the temperatures, and you can't say, well, we're close enough. Well, you're not close enough. We have to be spot on. I have a 12-year-old daughter. She's a princess. Again, if you've ever heard me, I talk about her a lot. She's the perfect child. And if she got burnt, yeah, hell would freeze over. I would lose my shit. And that's the way we got to look at it is, hey, these valves are there to protect your children, you, and then maybe even your grandparents, someone that is older, that may be just turning on a shower or just going over to wash their hands. These are all about the safety. So if you notice, I think maybe last year, Jim, did I do a mixing valve last year?
I think so.
Okay, so if you noted, maybe if you were on this last year, you're going to notice the look of these new digitals are way different from last year. Powers and ourselves have really been working on adding a lot of your guys' feedback, the contractors' feedback, and the end users' feedback of, hey, what do we want out of this valve? What would make this valve better? And I really think Powers killed it this year. They've spent about 2 years redesigning. I was lucky enough to be able to sit through about 3 meetings and add my input on it. And trust me, I'll tell you when one of the features pop up that I said, I'll let you know really quick. It was my idea. But the whole feature of the valve, even the layout of the piping, if you look at our old valve, we always had our hot coming up through the top or through the bottom, our cold coming through the side, and jumping up through our mix on the outlet. If you look at our newer one, what we've done is the contractor suggestion. We'd like both of them to come up right through the bottom. You know, when these are designed, they'd rather stub one up and just come straight up. Looks better, and that's the way those guys want it. So Powers jumped in and really changed it up and made it easier uh, for contractors and end users to install this. And then also when you get into the operations, it's pretty slick. So let's look at a couple of our features that we have on there. We do have our full touchscreen, our touchscreen on here. I believe it's like 6.5 inches, so it's a pretty decent sized screen, very visible. You'll notice that our control box is set up. This one is set up for a 1017, so this will be our master mixer. We have all of our listings. We are UL listed, and then also BACnet or Modbus. That is all built into this box. So if you have that system, or if the building that you're working with already has a Modbus or a BACnet or some sort of building automation system, we don't have to add an extra box to wire it in. You're able to wire that directly in to that system. If you don't have a building automation system and you just don't have that ability, maybe you're not a total Bowling Green or University of Cincinnati where you don't have all that extra cash to throw into a building automation. At the end, we're going to talk a little bit about Lexus. It's not my strong suit. We got to get the smart people to really talk about this. But I do understand that this is a new system out there where we're able to have a building automation system without having an entire system brought into, or into that project. So this is something that is at no charge. It's already pre-built in, and we'll talk about that a little bit at the end. So if we're looking at this valve, we see our control box, and we'll dive a little deeper into what all this is. But if you're looking at our side view, what we'll find is, we've gotten rid of the old style actuator that is actually operating a ball valve inside, where we're able to pull our temperatures and our sensors, run it through, and then it would turn a ball valve. What we found was with calcium buildup and debris in the water, I had a massive one up in northern Ohio where they had our large IntelliStations, and it looked like somebody dumped a load of gravel into it, and it was throwing off the torque. So what they've done now is gotten rid of that, and what we've done is we'll dive a little bit more into how this works, but we're able to jump into our actuator. And if you ever have to change it, work on it, look at it, they've made everything super simple to get in there. And that was one of my ideas, being a service plumber for so long. Stop making these so hard for us to access the problem areas when we design it. Let's set our actuator off to the side. Yes, it looks a little goofy sticking out there, but we have the complete ability to dive in, replace it, change it, do whatever we've got to do. After 10 years, everything needs to be worked on. So they really made it where you're able to dive into every feature of this valve and really work on it. Come up here to our top left, you'll see, obviously we've got our hot and cold water entering through the bottom. We do add service unions to both sides because, again, if you need to work on this one, we don't want people cutting things out. Just a simple 3 union, and then we're disconnecting it, and we can actually have the valve out of the system, either to change it or to work on it. Now, because this is so new, there's not a lot of things out there on the internet. So a lot of things that I'm pulling off and I've added is you're going to notice that small black line. It looks kind of goofy. You won't see that on the outside, but internally, what we've done is because this is our mixing chamber. It's quite large, gives us a lot more GPMs running through it. But when we running in and we talk about how this is operating, we were going back to that statement I made where if I've got my cold coming on the right, my hot on the left, what's happening is my cold staying on the hot on the left. I'm sorry, my cold staying on the right, my hot's on the left, and it's not truly mixing until we get further down that mixed water line. So what's now been done, and you want to look in to, is what we've done is we have actually added a baffle inside here. And what that's going to do is that's going to force, after water runs through this mixing chamber, it's going to come up and hit that baffle, forcing that water to turn. mix, and then head out. Instead of having two separates, we'll have a desired temperature right out the top by jumping into the blending end of it. Now, internally, this is our actuator. You're able to pull that, and then we'll get into our guide system now and our screw system and just show how simple this works. It's a very easy, simple feature, but you're able to see the backside of the valve. And then basically the brains of this operation is we're going to go all the way down to our standard fast actuating sensor, because now we've allowed a total blend of water right outside our chamber. Right above it, we'll have our fast actuating temperature sensor, which will pick up the actual legit temperature of our line, sending a signal back, and then allowing this to operate. And again, we'll jump into each individual fixture so you'll understand how they work. So what we've done, and this is kind of more of an internal view, as our water is entering, you're going to notice that we have our check valves. Okay, you don't want to have a mixing valve, and don't ever design something and saying, hey, I think we can get more water, because anytime you add anything into our piping system, such as check valves, obviously, you're going to have a little bit more of a pressure drop, but please don't design them without it. We'll have massive amounts of crossover. And one of our big ones, and this was not my idea, this was actually a guy that was out of more of our East Coast. They were putting these simple little checks in, but we're having issues because they were cheap, light springed, they were gumming up. So the idea that they took from a rep was, hey, we have backflow preventers, right? So this check valve is actually the same check valve that you're going to find in our basically Watts 007. So it's a well-built, tested check valve that really allows when our hot's starting to cross over, we'll have complete shutdowns. And I don't know if you guys have ever done it, but working on a building cross, we've got hot water in the toilets and cold water coming out of the bathtub on both sides. It's an absolute nightmare, and you'll spend hours upon hours trying to find out that, hey, I have one bad check valve on my mixing valve. So what they've really done is they've ramped this up and added some really decent sized checks and actually rebuildable. So it's kind of nice. Internally, where we used to have a large ball valve in here, where we had 3 ports, where we would have our hot hole on this side and our cold on this side, and that ball valve would spin just back and forth. What we did is they've redesigned it, and now we're using more of a globe valve shuttle. And this actual ball that's inside here, it's all in stainless, will actually go back and forth. All right, and I actually got a small video showing this operating, how it actually operates. But we're blending more with a shuttle now, where we're able to convert our actuator to actually physically screw this in to allow more hot, unscrew it out to get more cold. And because they've added such a fine thread, we can really dial in on those temperatures, because 120 is 120. It's not 120-ish. We want that to hit directly on the spot. So as you can see, and when we jump into this, we have our mixing valve and our mixing chamber, and then we've got our control box. And really, truly, the only sensor that you'll have if we're using this just as a single mixing valve when bought, our old one and now our new one, we will only have just one sensor, and that's our fast actuating sensor. So as we're blending water, that water will blend through our chamber, go through the baffle to mix it, and then our sensor is going to pick up exactly what that temperature is. Too hot, too cold, regardless, it'll send a signal back to our box, allowing us to know what our temperature is, then sending the signal back over to our actuator, allowing this to screw in and or screw out to hit that exact temperature that we need. And again, we'll have 4 ports on here. So our first top left will just be for our fast actuating. And then our top right, bottom right, that's just going to be for our actuator. That'll be our power in. And then also you'll find out our new sensors that we've chopped in there will all wire into one hole. Or I'm sorry, we'll wire into 2 holes, but it's just one actuator sensing. Now let's look at our board. The board's pretty slick. They've made it as clear as possible. That was another idea from another rep is, hey, let's make this as clear as possible. You know, when these guys want to see it, we don't want them squinting, putting their hand over it, taking a picture and zooming in. So what you'll get is you're going to, when you open up your system, it'll automatically give you, where's my mouse at here? Wrong computer, sorry. On our circle, we're going to have our set point at 120 and our mix outlet. Looks like we're running just slightly high, about 1 degree, but this is what you're going to see. Now on our older systems, when we're using our single valves and not a totally built valve, we never had our hot inlet temperature or cold inlet. And now they've added features where if we're going to buy this valve and we've decided, hey, this is the valve we want, this is what we're going to do. But, you know, Todd, this thing only has one sensor. My idea, please write that down, this was my idea, is to actually add an additional kit that if you want all the extra features to be read, you're able to drop down and jump into, one a little quicker, into adding additional sensors. Nothing's going to be invasive. We don't have to jump into it, and we'll talk a little bit more, but we're able to dive in and add additional sensors where it's needed and when we want to use that. So if you want just a standard mixing valve, we're set. If you say, hey, I want more features, I really want this thing to dial in, we can add additional sensors on our hot and our cold, on our return line. And what's really nice is they've actually taken that sensor and not made it just the temperature or pressure. They've dialed in so each sensor is for pressure and temperature at the same time. So we only need 4 instead of having you guys order 8. So internally, this is how we work. This is how it's looking. And hopefully you guys can see this. But basically, as this thing's operating and our actuator's hopping in, you'll notice that it's screwing this in and out, basically allowing more cold, more hot, and it blends it back and forth. We will have total shutoffs as we go all the way to the end and shut. Right now, we're doing a really basic, but it should scroll over, and eventually it'll stop doing a 100% positive shutoff on that cold or on that hot, or however we want to do it. If we do have a power shutdown, if we lose power, obviously very important, just because you don't have lights doesn't mean you can raise your temperature of your shower and your eye washes, you know, or just to the building itself up to 160. So in the event of a power failure, what's going to happen is this is automatically going to shut the hot off. All right, so you're only going to get cold water through. And I know someone's thinking, well, you know, don't shut it all the way off. But our issue is if the lights are off, you shouldn't be taking a shower. So we'd rather have this shut off in the total cold position, allowing cold water to run through the system, because no one's ever died from getting splashed with cold water, but people have gotten very, very injured when getting splashed with hot water. So on the power surge or on a power loss over time, this valve will jump in and actually shut the hot off completely, allowing only that cold water to hit that building. All right, also on our board, a couple other features that we've added is we've upgraded our actual control box. Now, if you look inside here, you don't need all these features, but what we've done is actually just added everything to you. We just gave you every option possible, and that way there's no way for anyone to say, man, I wish I had, or man, it would be really cool if we had this. What they've decided, and they work directly with Techmar controls, which are really great at jumping in and building a box that's going to give us everything. So obviously we'll have our main power coming in. They've also given us now power not just for one pump, but for 2 pumps. So if you want to control your circulation pump and you want your control box to actually control it, we have the options now to control up to 2 different recirc pumps. We have our alert power. We've also added in for automated isolation valves. If we need these in the system, we're able to now wire those up into our control box and save a bunch of extra equipment just to do that. Obviously, our mixed outlet flow sensor. We'll talk about that a little bit because I'm starting to get a lot of requests. Our sensors on our return, pump control, Building management, if you've already got the Modbus or the back net, bang, you can just wire it in. We don't need to add additional features. The other one, not my idea, another rep's idea, is adding in when we want to actually add two of these. If we want two mixing valves, how are we able to tie these together where maybe we want both working at one time? Maybe we want a lead lag. One will work for a day and the other one will work for the day. They've added a really nice benefit where we're actually able to wire up and tether both of these mixing valves together and actually work on itself. Now, the last one is this Ethernet cable. I'm not a big computer guy, but they did tell me when you plug Ethernet in, you don't have to worry about lost Wi-Fi. And as you guys know, you guys are never setting these up or having these installed in a clear area. Normally, these are in some sort of boiler mechanical rooms in the basement where if maybe we don't even have Wi-Fi, a Wi-Fi down there. But we really need it. We want to keep track of this. We've given the ability where you're able to hardwire this up right with an Ethernet cable. So we've got good communication skills running through it. So a couple other features when we're looking at, is this valve working? And for years, we were able to come up here and say, yep, everything looks great. But we would get a call. Hey, Todd, you came in at 2 o'clock in the afternoon yesterday. You got all of this set up for us. We're super happy, but man, the next day we start having issues. So now what we have on this screen, nothing needs to be added, no extra features to buy, is we're able to actually come up and pull our graphs. All right. Now these graphs are, they kind of look confusing, but what's really nice is we are able to really troubleshoot, find out what's going on. Why? One day everything is great. The next day it's wrong. We have a routine alerts for between 6:30 and 7. And this is actually a legit job. Nothing that I worked on, but they were having massive problems and they had a lot of complaints just in this half hour of what's going on. Once we were able to go up to our control box, hit our graph to find out what's going on, we were able to find out we had some massive ups and downs. Well, now that we can see it, and this is actually, this is actually set up for every single minute. So every minute, this thing is reading exactly where we're at, either our mixed outlet, our set point, our mixed in, how much are we blending? This all shows. And what this graph really dialed into was why between just those 30 minutes? Why are we running into those problems? And by checking the graph, we were able to find, a minute's a little rough. That's a little tough. We can move that out to 10 minutes a day, a month. But they found out in this building that it wasn't the mixing valve. It was that they were turning on their dishwashers and the laundry was dumping everything at one time. So we jumped into, well, it's not the mixing valve. We were able to troubleshoot it quickly to find out, hey, we're turning on a lot of equipment. We're having a major drop and we're losing a lot of water in the heaters. We're able to adjust that and then get them right back up online. And again, we were able to do that by just seeing those graphs. And this isn't something you're going to have to request from us or from Powers. We can just jump right on our box. That's standard. Open this up, set where we want it. If we want it every minute, every 2 minutes, however we want to do it, we can dive into that. Now, if you want a full system where you got everything, and we're able to pull it up, pull it down, that's where we'll get into, hey, you know what? I want a little bit more than just what the features show on the box. Let's jump into a building automation or like a Modbus or a BACnet. Let's have them send the data over. Well, again, that all takes time. It also takes money. So we'll get into where Nexus being connected is really going to help out on troubleshooting. So here's a couple other universities that we're running into where our graphs are not holding tight. We're jumping up and down, but we're able to really jump into the troubleshooting and what can we do. And honestly, as a rep, this helps me out tremendously because normally we show up to the job, we're working with the engineers, the end users, the contractors, and we're kind of made, hey, figure this out. Well, now I have the ability to jump on, look at some graphs, look at where we're working at. When are we having our pressure drops? When are we, when are our temperature spiking, dropping, and to see the exact day, time. And then we're able to look back at the schedule and find out, hey, what were you doing at this time and why were we jumping on this? So couple of new accessories that we've added, and we talked a little bit about adding the sensors. And then we also added in, thank you, Jim. We've also added in, now we have a clamp on flow meter. We used to have to cut these in. It was a little invasive, or we were able to dive in and cut these things out. But now we're able to do a clamp on. So this is very nice that we're able to add this feature to an existing or add this to a new feature. And what's nice is they've made it really, really simple for us, that when we go to tie these in, you don't need to cut new T's, new ports, and have the right size. Because, if I have a sensor here and my tip's only sitting out maybe a half of an inch, I'm not going to be able to cut in a 1-inch T and add a 1-inch female adapter. Our sensor would never hit that. And this was brought up by some of the contractors that, hey, add ports that we can add different features later down the road. And that's what they've done. On our service union, this is actually what it would look like if you bought it without any additional sensors, or you say, hey, I want to add some things in. We're able to pull a C-clip, pull our plunger right out of there, and then insert our sensor right into there, and then drop our C-clip back in. And then you're done. We're ready to go. We know we have the right depth. We know our sensor is dropping into the actual moving water and not just sitting in a dead zone. And what's also nice is now we have just 3, and we will have 1 for the return. But we would just have 4. But normally when we have 4, we would have to consider that 8, because normally 1's a temperature and 1's a pressure. So what they've done is they've redesigned this to add each sensor is pressure and sensor. And that way we can really cut down on the amount of sensors and the amount of wires we have kind of rolling into this. So again, it's a really nice feature, kind of for everybody. Someone that just wants to throw it in to do the mixing. They're not worried about all the additional information. Maybe they're just not set up for it, or the maintenance guy has no interest. He just wants to keep it. But then we go up to, say, a Bowling Green University where I work out a lot. They want to be connected on everything, and this is a great feature for them that we say, hey, we want to add this on. We're able to add different features as we move into each different project. I really do like this flow. Working with hospitals, a lot of times when these are sized, they take, a total fixture count. And on that total fixture count, we're trying to come up with, hey, what's going on with this system? Why are we having issues? A lot of times when we're able to add in that flow sensor, we're able to actually see real data of how much water is being used on any given day, any given hour. And we're able to relate that back to find out, hey, maybe a troubleshooting. I've had a couple of them where the copper was pitted out so bad, and now it's just because it was undersized and there was a lot more flow. And because that flow was screaming through that return, we start getting a lot of pitting. Now what we did is we actually added a flow sensor, but on that one, we actually had to do a shutdown at 2 in the morning to cut this all in, to put that flow sensor in the return or into that mixed out, or on that return. We're able to jump in and just clamp something on, wire it directly in, and get pretty accurate information of how much is being flowed through that device. And again, very simple. We've already got it set up where no extra features. We're able to wire it directly in, plug it directly into our 110, clamp it on the pipe, and then get those readings directly back. So a couple of the other features that we run into, and a lot of my problems, and I bring this up, I know nobody on this webinar sizes anything incorrectly, but for people that aren't on this webinar, I do get a lot of piping issues. So I do put this one up there. And I will tell you a couple of the features when we are piping in or designing one of our systems. I want to throw it out there that we always want our circ pump. And please make sure that this circ pump is upstream of our cold water bypass. So we want this actual water to be pushing through our cold water bypass and then heading back to that boiler. But this is just kind of a feature setup showing what it looks like actually in the system. And it looks like we have all the additional sensors wired up into those. So it's a really nice, clean look. Now we jump into, we have a valve here, but say we're going to act like, man, this is a large 2-inch valve. And on that 2-inch valve, we decided to go with 2-inch because, again, like everything, we got to hit flow rates. We need to know what's going on. So we're going to take our fixture count, we'll add it to a Hunter's curve, and then find out what do we need to do to really get this working where we want. And say you're coming up with, a capacity of roughly about, I don't know, 140 GPMs. At 140 GPMs, we're really going to need a large valve. Well, my issue with adding in just one valve is great. It's going to work. But say we have a problem with this valve. What do we do? We don't have any mixed water. So a lot of times what I'm doing is I'm talking with you guys, I'm talking with the end users to start jumping into more of a dual system. Now I know you're thinking, Todd, you're being a salesman, you're just trying to sell two instead of one. But actually what I'll do is I won't add two 2-inch to the system. What I'll do is I'm actually going to drop these down and I'm going to make them both 1-inch. So we'll have 1-inch in, 1.25 inch out. And the reason I'm doing that is because I need to hit that 140. But if I come over to my spec sheet and I say, okay, I need to design this, I always start off with a 10 PSI drop. And I'll say, okay, at a 10 PSI drop, this little small 1-inch valve is able to do roughly 73 gallons a minute. Well, now if I take 73, 146, now we're over top of what we need. We have two different valves, which give us our capacity, but it also, just like everything, is going to give you that redundancy. That way, if I do have an issue with one of these valves 5-10 years down the road, I'm not sitting at a senior living center saying, hey, this is not working. We're in big trouble. Now we've got to drop all of our heaters down to, that 118 and 120 to make sure, because technically you're going to have to go back and start adjusting everything. So doing more of a dual system, and trust me, when you look at the pricing of one 2-inch valve versus two 1-inch valves, you'll find out it's pretty close. We're not, we might be slightly over adding two valves, but it's definitely not doubling the price of the entire system. But it gives us that ability that, we're able to we're able to actually work off of both valves at the same time. Problems, don't worry, we got some redundancy, we're good. And then again, I've talked to you guys, we're actually able to add jumper cables over. So maybe instead of working off both, we can lead lag on both systems there if we've sized these correctly. But we have the features, but dual valves have really saved us a tremendous amount of time when in emergencies where, hey, we've got an entire university where I'm working with Cincinnati Public Schools a lot. If it goes down, there's a lot of screaming and yelling when we have extremely hot water, extremely cold water. So it gives that ability where we're able to add two different valves in, and they're able to talk to each other, they're able to work together, but then we're also able to troubleshoot that. So now we'll jump into a little bit of our connectability. Nexus is something that Watts has started. It's a new program. It's kind of like their own building automation system, but what's nice is we don't need to come in and wire the whole building. We're able to work off Wi-Fi, work off the computer system. And what's also really nice is we don't need to pay for a lot of this. A lot of this is already going to be built in. As long as you jump in, you register your product and you start using it. Nexus is a new platform that Watts has designed that gives us that ability to now be able to say, hey, I have my own building automation system without jumping into hundreds of thousands of dollars to wire the building. You already have it. Everyone's got a cell phone. Most everybody's got a little iPad that they're walking around with. And I know everyone on here's got a computer, because if not, you wouldn't be hearing me. But we're able to build this up. So why connect your equipment? Okay. One of the big ones, and this is what we came up with, is we want people to connect it because we're able to come back and design it. So if you buy one of these mixing valves and one of our digitals are thrown in there, if it's not connected to anything, if you just install it and walk away, we will give you a permanent 2-year limited liability warranty. Now, if you jump in and you say, hey, I don't want to connect this, I don't want to go through that, but I'm going to register it with Watts Powers. and just say, hey, this is registered. This has been installed. It's been installed on this date. We'll have some information being registered. Now we jump up, just registering this piece of equipment brings you up to a 5-year limited warranty. And you say, you know what? I am going to connect it. I'm going to jump in. Looks like we don't need to pay a bunch of money for this. I can just register it, get it set up. If you actually register it and connect it to the Nexus portal, now we will actually give you a 7-year limited liability. Okay, so just these features alone, and we're not telling you got to pay for Nexus. We're just saying, hey, we're giving you some features where we can really jump up. And 7-year warranty, that's tremendous. You won't find that out there. Okay. Again, why would you connect it? Know that the equipment that you put in is actually working properly. Get the alerts. If we go back to that board, if I just looking at my control screen and I have a low temperature, a high temperature alert, it's not going to set off sirens. And we're just going to wait for the maintenance or someone to walk by to see it blinking. So get those alerts. So when you're working on the east side of Ohio, but maybe you have your building on the right end or the west side of Ohio, you're going to get that alert. Hey, we've got a problem over at this building. What we can also do is what we're working on with a couple school systems, say one like Cincinnati Public, where they have 55 buildings. We can actually jump in and connect all of our mixing valves on one platform, not one platform for each individual. So now we can start tying in multiple units throughout the entire school system. And they were able to not release him, they didn't fire him, they moved him on to something else, but he didn't have to do his monthly run and he drive to every single school and just take the readings. They're able to pull it up. So also, if I can do it, trust me, you guys can do it. It's 3 quick steps. Register, connect it, kind of like a why not. You're not doing anything, but it's a pretty quick, it's an easy 3-step setup. You can invite multiple users. So if you just want you on it, or if you say, hey, I want you on it, I also want my engineer on it, I want my plumber on it, everyone can kind of see what's going on. And then also you can add additional users. When we add our users, now we can also let them know what we want them to do, what we're going to allow them to do. We don't want every, Tom, Pete, and Paul out there being able to come in and to adjust their valves, from our phone or from an iPad. So you can restrict from what one person does versus the other. It'll give you a complete board. It'll actually give you your building, what you're using, locations, exactly where your temperature is, and then show you every alert that may have come in when you're not there. So maybe we're getting a low temperature alert in the middle of the night. You're not going to know it, or they won't know it until they walk in the morning. And normally that's when the plumber gets called, the rep gets called that it's broke. But now we're able to open up and see exactly what's going on with these features. So we're able to jump in a little bit more on our home screen. So as you can see, this system right here, just our first page, we've got 6 pieces of equipment set up. We have over 23 sensors set up, over 5 locations. And we're able to say, oh, we do have 1 high alert. Oh, we had 2 high alerts. Now we're able to jump over to our board and see exactly which location, what's going on, and why are we running into these alerts. So it's a pretty slick little system. Again, you don't have to be a computer guru to jump on it. Again, if I can tie onto it, trust me, any of you guys can jump onto it, because I just learned how to send emails like 2 days ago. So that's why I got Jim in the same office. He walks me through everything. So this is another one. Sorry, it's a little bit blurry on this one, and I tried to get my features. But this was one where we had massive problems, but again, it was only at one part of the day. One part of the day, we had multiple complaints. But again, being able to jump on, really dial into exactly what time, what day, we were able to see that, hey, we had a complete drop off of temperature. All right. And now on this temperature, again, that's where we found out that they were actually putting in, this was a prison, they were dumping in massive amounts of sheets. All 5 wash machines, which are massive, they're size of like a freaking house. The guy was walking through and just turning all 5 on at one time, which was making a massive dump, massive dump. And then we were getting those drops in there. And yes, before anyone asked, this laundry was hooked in to the mixing valve stations, and they're using chemicals for more of the treating and not the 160-degree water. I know someone's thinking that in the background. But this was a nice feature. We're able to jump in and then find out, hey, exactly what time, what degrees, and what was going on. And we're able to fix the system pretty quickly. So my whole scenario of why digital, why would we go digital? The way I look at this is, we're going to come over to our old thermostatics. They work. They always work until we have a problem. And that kind of reminds me of the old flip phone. You could open that up. You could dial a phone number. If anybody else is my age, you probably remember trying to text off one of these things. It took a lot of time to get it to move and to get everything to work. And that's what this is. It's just old school technology. Will it work? Yes. Has it worked? Yes. But it's more of like a flip phone. We're not going to be able to get any benefits out of this. Now, moving over to more of our digital world, that's kind of more of a smartphone. If we want to look into this or looking at that, this just gives us that ability to dive in, really get some good research on any digital mixing valve that's out there. Much more accurate, much more information. And again, I don't have to drive all the way back to my office. If we hook it up to something like a Nexus, we're able to see everything that we got right on our cell phones or right on our iPads. So I know when I do a lot of these and I do a lot of these webinars, nobody wants to wants to ask me any questions because I know what you're thinking. I'm not going to ask a dumb question. Someone's going to call me out. So I've given you guys my direct email or my direct cell phone. If you've got additional questions after this or 2 months down the road, whatever, feel free, give me a shout. I'd love to talk to you and we'll kind of work on, designing, troubleshooting, or anything you got. So I appreciate the hour, guys. I'm only 3 minutes short. I'll let Jim take back over and we'll answer any questions that pop up.
Thanks, Todd. We actually do have one question. I can't answer that. Oh, come on.
Union rules.
So does this mixing valve have the capability to fail to manual set rather than cold?
I believe right now, off the top of my head, it's going to fail into the cold position. But I do have the engineering staff, which I will answer that question. Can you if you can get me your name, number, I'll get that information back to you today. If it's a yes or no. And if it is a yes, I'll explain all those details. Over this webinar, I'm going to say no, just to cover my butt. But I'll definitely look into it for you.
Okay. Well, thanks again, everybody. This is actually our last DMAU class of 2024. Stay tuned and be on the lookout for the next class schedule coming up for 2025. And yeah, if we don't speak to you again, hope you all have a Merry Christmas, Happy Holidays, and a Happy New Year. Well, thanks again, everybody.